In this video I'm going to review some basic stuff about Python, but I'm also going to introduce Visual Studio Code, which is going to be the main way that we use and interact with Python in this course. So I'll go to the search box and I'll put in code, and it finds the Visual Studio Code app for me. So I'm going to start that up. Okay, so now we want to open a folder. So it's usually the best thing to do when using VS Code that we don't open individual files, but we open a folder which we put all our files in. So here I've made this folder called Python, and we're going to open that. Okay, so now up here you see that here's the list of the files in this folder. There's just the one file that's called hello.ipynb. So let's just open that. Okay, so this is a Jupyter notebook. So we'll talk about that in just a second. But we just also mention a couple of other things that we see around here. This thing here is highlighted at the moment. This is the Explorer, which shows us the list of files. Or we could also go to this thing here, which gives us a search box, which will search all the files in this folder. There's only one file at the moment, but it could be useful if we had lots of files. This is about source control, which we can use if we want to manage, keep track of all the changes we've made in our Python files, but we won't deal with that later at the moment, but we might have a bit of a discussion about that later. Similarly, this is about debugging, and this is about extensions. So I should mention that in order for any of this stuff that we're doing with Python to work properly, we need to have some extensions installed in VS Code that deal with Python stuff. So we've got the Python and Pylance extensions and a bunch of other extensions to do with Jupyter notebooks. And we can hover over any of these to see some details about it. So we might have some separate instructions about how to make sure that if you've got VS Code on your own computer, that you've got the right extensions installed, or how to make sure it's all set up correctly if you're using the university machines. And then there's a thing about testing your code, which we'll look at later as well. At the moment, let's just look at this thing here. So this is kind of a mixture. We've got some Python code here, and we've got some sort of text cells that like commentary and so on. But, let's make a new file. So we go up here, and then there's this little icon here that we can click, and we're going to make one called arithmetic. Okay, so this is a new Jupyter notebook. Let's work out 2 plus 2. So we're just going to enter 2 plus 2 here. And if I just press return, then it'll just give me another line, which is not what I want. If I want to actually submit it and make it do the calculation, I have to do a shift and an enter. Okay, and so now it's giving me that the answer is 4. Okay, so let's try and do something a bit more complicated. So let's maybe look at, let's think about Pythagoras theorem. So let's remind ourselves what Pythagoras theorem says. So we're going to put in a text cell here. So we're going to click up here, and it says plus markdown. So markdown basically just means a text cell. So I'm going to say Pythagoras says that a squared plus b squared equals c squared. And we can do this in LaTeX here, so we're going to say a squared plus b squared equals c squared. Okay. Now you see it's still just showing me the kind of LaTeX code, but if I do shift enter, which is what you normally need in order to process it, now it turns out into nicely kind of formulated mathematics. Okay. So let's check an example of Pythagoras. So typically, simplest example of a right-angled triangle is 3, 4, 5 triangle. So let's do A is 3, or actually let's do it this way. We can A, B. So it's possible to do this kind of multiple assignment in Python. So we can say A, B, and C are 3, 4, and 5. Okay. So now we need a squared. So we could just do a times a plus b times b. And then we want to compare that with c times c. So let's do them as a pair of things, a tuple. So we put a comma in, so it's going to tell us both things, and they're both equal to 25. Yeah, that's good. So Pythagoras is verified in that case. And now I'm going to go back. So this is another thing to note about Jupyter Notebooks. I can go back and sort of change what I did already. So I've just gone back here, and let's actually put in a double equals sign here. So I put in a double equals. Remember that's a test. So double equals tests whether the left-hand side is equal to the right-hand side. So again, to submit it, we have to do a shift enter, and it tells me it's true. And actually, you might have noticed something flash up whilst I was doing that. So let me delete that again, and now maybe you can see that this C has a little twiddle underneath it. And this is one of the kind of advantages of using an integrated development environment like VS Code, is that it does actually understand Python syntax, and it knows what's correct and what's incorrect, and so it knows that at the moment what I've written here is not syntactically valid because I don't have anything sort of between the B star B and the C star C. And if you actually hover over the C, it says statements must be separated by new lines or semicolons. Right? So that's some kind of indication of what's wrong here. Well, it doesn't really tell you exactly. It doesn't really tell you exactly what's the point. The point is that we wanted to put in the double equals sign there. But anyway, you'll find lots of the time as you're typing stuff, well, if you make mistakes, then VS Code will give you some kind of indication where the mistakes are by underlining things with these little red twiddles, and you can hover over them and see what happens. So there's that. Okay, so there I did it A star A. Of course, when I entered in LaTeX, I did an up arrow. Now, up arrow, what we could do, A up arrow 2 and B up arrow 2 is C up arrow 2, but it turns out this is actually not the correct syntax in Python. It's the correct syntax in LaTeX, and it just happens to work out. Let's actually do it with a comma instead. Okay, so A up arrow 2 and B up arrow 2 is 7. Yeah, that's a bit weird. This is actually because the up arrow is in fact a bitwise operator. It's not raising to a power. So what we really want here is a star star. That's the correct Python notation for raising something to a power. Okay. So another thing we could do, let's do 9 ones, star star 2. That's a kind of curious calculation. You see that this, if we take 9 ones and square it, then what you get is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 7, 8, and then 9, 8, 7, 6, 5, 4, 3, 2, 1, backwards. So it's a nice little exercise. So that's multiplication and raising to power. Let's think about division. So so 99 over 10 does the obvious thing, and you should distinguish that incidentally from 99 /10. So double slash is integer division. That's truncated division. So that's guaranteed to give you an integer. So that's the so if we try and do 99 and divide by 10, you want the quotient and remainder. Then there's your quotient. There's the 9. If you want the remainder, when you divide 99 by 10, well, that's going to be 9 as well, of course. So let's look maybe at powers of 2. So this is another reminder of a bunch more things that we can do with Python. So I'm going to do 2 star star I for I in range. Let's say 100. Okay, so let's think about this. So we've got square brackets. That means we're making a list. And what's the list? Well, it's reasonably easy to read this. This is 2 to the power I, all the powers of I for I in the range up to 100. But actually, I don't want the powers themselves, but I want the powers themselves, and I'm going to reduce them mod 19, say. Okay, so this is giving me this is giving me a list. Unfortunately, this is kind of giving me this vertically. I'd really rather it gave it to me horizontally. So, well, I guess that gives us an excuse to remember about a different kind of thing. So The easiest way to make it do it horizontally is to make it into a numpy array instead of being a list. So we're going to do import numpy as MP. So all these kinds of things that I'm doing here, we'll go through them in more detail in later videos. But for the moment, I'm just getting a very quick scan through a bunch of things we can do. So so I'm going to put in np.array here. So notice here I need to do this in brackets, and notice that as I've done np.array, I'm getting this thing popping up, which is telling me about in horrendous detail about all the things that I can do with np.array, but that's probably a bit too much information. And then I've got my open bracket again. That's I've got that's in red with an underline. Because I haven't closed that bracket, and actually if I hover over it, it says at the top here, you see it says bracket was not closed. So now I'm going to close it. Okay. Okay, so now I've got these things as an array, and you see it goes 1, 2, 4, 8, 16, 13, 17, you get all these things here, and eventually you get down to 1 around here again, and then then you find that this sequence repeats. It goes you've got 1, 2, 4, 8, 16, and then 1, 2, 4, 8, 16 again. Now 1, 2, 4, 8, 16, 1, 2, 4, 8, 16. So that's a nice little thing, piece of interesting thing from number theory, which we can maybe discuss later. Okay, so that's just a few basic things that we can do with arithmetic in Python, and I think we'll leave that there for this video, and we'll do all the individual pieces of this we'll do in more detail in separate videos.